This is a video for AQA Further Pure Mathematics. This is Complex Numbers section 1.4, where we're looking at dividing complex numbers. Well, before we actually start looking at division, I'd like to consider the following type of multiplication. So remember, when we're multiplying these, we can use FOIL. So if we multiply the first terms, we get 25. The outside term is plus 10i. The inside term minus 10i, and then finally the last terms give us minus 2i squared. So that's minus 2 squared and I squared, so in total minus 4i squared. Now you'll see that what happens here is, because we've got plus and minus of the 10i, then this part of the calculation, the imaginary part, becomes 0. The other two parts, the 25 and the minus 4i squared, because I squared is negative 1, that's 25 plus 4. So we end up with a total of 25 plus 4, which is equal to 29. Now, so this is a special type of result where we're multiplying two numbers, one which is plus something times I and the other one which is minus something times I. So this is similar to using the difference of two squares. In fact, it is the difference of two squares, but we're using the difference of two squares with imaginary numbers. And so the types of numbers, such as this one, 5 minus 2i and 5 plus 2i, these are known as complex conjugates. We can consider conjugates in general. So if we've got a minus bi multiplied by a plus bi, same as before, we'll see that we've got the first term a squared and the last term minus b squared I squared. And then the middle terms are both a times bi, but one of them is negative abi and the other one is positive abi. So those two parts disappear, and we end up with a squared plus b squared, which you can, if you wish, learn as a general result. Before I consider an example of division by a complex number, just wanted to first of all look at what happens if we're dividing by I. Then this is a reasonably straightforward one, because if we've got 3 plus 2i divided by I, then we can multiply the top and the bottom line by I. So we get 3 plus 2i multiplied by I and divided by I multiplied by I. Multiplying out the top line gives us 3i plus 2i squared, and on the bottom line we get I squared. Now, remembering that I squared is equal to negative 1, this is therefore equal to 3i and minus 2 divided by minus 1. And so then taking that minus 1 and writing it in the form we've been asked to do, with the real part first, this becomes 2 minus 3i. So there it is, typed out rather neatly. And remember that what you're doing is you're taking the denominator, which was I, and trying to create a real number on the bottom line. In this case, we simply need to multiply by I itself, and that gives us minus 1. When it comes to a more general division, for example, we've got 4 plus I divided by 2 plus 3i, then to make the bottom line into a real number, we've got to use this idea of multiplying by the complex conjugate of 2 plus 3i. So that if we multiply the top line and the bottom line by the conjugate of the denominator, we're multiplying by 2 minus 3i top and bottom. It then becomes a process of two sets of multiplication for the complex numbers. So if we take the top line, the first term is 8, and then we've got plus 2i minus 12i, and then the last term minus 3i squared. and similarly on the bottom line. So we end up with 8 minus 12i and 2i minus 3i squared on the top, and on the bottom line you can see we've got 4 minus 6i and plus 6i, so that's the conjugate at work there. Those two parts are going to cancel out, and then minus 9i squared. So if we look at the top line first, the numerator, we can see there we've got two real numbers, 8 and minus 3i squared. So minus 3i squared is plus 3. So we've got 8 plus 3 is 11, and then the imaginary numbers are minus 12i and plus 2i, so in total minus 10i. The bottom line is just 4 plus 9. Remember, we've got the a squared plus b squared if you want to remember it like that. So in total we've got on the top 11 minus 10i divided by, on the bottom line, the denominator 13, which, writing it in the form a plus bi, is 11 over 13 minus 10 over 13i. So the idea here is to multiply by the conjugate of the denominator. Well, that's the end of this video. In the next one we'll be looking at terminology for complex numbers.